Hey guys, it's Adam, Science Tutor, and today we're going to be talking about the heart and the different anatomy of the heart and the way the blood flows through the heart, which is a very important topic in all anatomy lessons. So there's 4 chambers of the heart. You're going to have 4 chambers, definitely put that up here. So you're going to have 4 chambers of the heart. You're going to have 2 ventricles and 2 atriums, which make up the 4 chambers of the heart. Extremely important to note that. So to start things off, we're going to draw both ventricles of the heart. And when looking at, you're looking at it anteriorly, so pretend like you're looking at my own heart. So left is going to be on this side, and right is going to be on this side. So you're going to have your left and right heart, left and right ventricles. So you're going to have your ventricles here. And these ventricles are going to have different valves. Talk about what that is, and then we'll talk about what this one is too. So we're gonna have that valve, and then we're gonna have 2 valves right here. Another chamber. This chamber is going to be your atrium. That's your left atrium. 2 is going to have also an atrium and another little vein, and this is going to be, we're going to talk about the veins in just a sec. Okay, and the muscle, there's going to be a muscle surrounding the heart. There's going to be your apex of the heart, is down below. Apex of the heart, muscle around the heart. The muscle on the left side of the heart is going to be thicker, and you're also going to see another muscle attached, which is going to be called an auricle. You have an auricle on the right side, but it's going to be very small. And it's going to be small because it's deoxygenated blood, and you don't need as much pressure. It's not going as far on the left side or on the right side. Excuse me. So let's get things started on the left side of the heart. So left side, just for simple detail, there's our left ventricle, this is our left atrium, our left auricle. This is going to be our pulmonary. This is going to be our aorta. So this is our aorta. And aorta is responsible for pumping blood throughout our entire body. So it's all our oxygenated blood through the aorta. And then we're going to have the pulmonary veins right here. Pulmonary veins are going to pump oxygenated blood into the atrium, and that's going to open up this valve right here, which is going to be called the bicuspid valve. So I'm going to see if I can switch colors here. So I'm going to use red for oxygenated blood. So it's going to come here through, there's 4 pulmonary veins pumping into the right atrium, and it's going to automatically open up this bicuspid valve, and it's going to go from high pressure to low pressure. There's nothing, this is empty. So it's going to gush in, and about 2/3 is going to fill with oxygenated blood. The remaining 1/3 of the ventricle is going to be filled up using both the auricle and the atrium and the surrounding muscle, and it's going to push with a lot of pressure the rest of that 1/3, and it's going to fill this up enough to open up your aortic valve. So you have the aorta, and it's going to have the aortic valve. So aorta or aorta valve. So cool, let's just run through that again. On the left side of the heart, you're going to have bigger muscles because there's going to be oxygenated blood, which requires more energy, more pressure to push oxygenated blood into the left ventricle. It's going to fill up, and with the muscle, it's going to push it through the aorta. And think about how much pressure and how much muscle mass you need to push oxygenated blood throughout our entire body. You're going to need a lot. So it's going to have bigger muscle, it's going to have a bigger auricle, and the atrium and auricle are going to fill and push that blood straight through this bicuspid valve, and then once it fills up, it's going to go right into the aortic valve, push that open, and it's going to go through the aorta and fill and feed the rest of our body. So cool. That's pretty much covers the left side. And we're going to get through to the muscles in just a bit. So on the right side, we're going to have our pulmonary trunk right here. And we're going to have the superior and inferior vena cava veins. So it's usually just called the vena cava, but this is the superior trunk and this is the inferior trunk. And they're going to come and it's going to push deoxygenated blood into the right atrium. So it's going to have deoxygenated blood, and it's going to push it into the right atrium, and it's going to fill this up. And you'll notice that the auricle is much smaller on here. And why is that? Well, deoxygenated blood requires less pressure to move, so it's going to need less muscle. It's going to have less muscle, smaller, if any is seen at all, auricle, and it's going to go straight through this tricuspid valve. So the blood is going to go from the superior and inferior vena cava into the left or right atrium, and then it's going to go through the tricuspid valve. It's going to go through the tricuspid valve, and similarly, about 2/3 is going to fill up with 2/3 of the ventricle is going to fill up with blood, deoxygenated blood, and then it's going to, with the muscle and the pressure, pressure's going to go low to high, or high to low. It's going to come out of, guess the valve name. If this is the pulmonary trunk, that's going to be the pulmonary valve, which is going to open, and our deoxygenated blood is going to go one way, both ways, and this is going to go to our left and right bronchi and lungs, and it's going to become oxygenated, and then guess where it's going to end up? Going back to, after it gets oxygenated in the lungs, it's going to go into the pulmonary veins, and it's going to be pumped right into the left atrium and left auricle, and then pumped. It's going to be a repeated process. So main things to get away: on the right side of the heart, you're going to be getting deoxygenated blood from the vena cava. It's going to fill up the atrium, and it's going to go through the tricuspid valve into the right atrium. The right atrium is going to then push, with the pressure it has, up into the pulmonary trunk, where it's going to go into each of your lungs, your bronchi. And then from the lungs through the pulmonary veins, there's going to be 4 pulmonary veins. It's going to fill up the left atrium with oxygenated blood. And oxygenated blood needs more pressure, needs more energy to move, so we're going to need more muscle mass. So we're going to have a bigger auricle and bigger atrium, and it's going to push the blood through the bicuspid valve and fill up the left ventricle about 2/3 of the way. The final third of the blood will be pressured by the auricle and atrium and surrounding muscle through the aorta, and through the aorta we'll separate it out, and it'll go feed the rest of your body with blood. It supplies the blood or the oxygenated blood for our entire body. So you can imagine you need a lot of pressure, and you need a lot of energy to move and motion to move all that blood up and out. So let's talk about the muscles. So we're gonna have three different muscles on the heart. We're gonna have one that goes all the way, I kind of already drew it, all the way around the heart, and that's gonna be called the peri, which means around cardium. So pericardium, peri's around, so it's around the heart. You're then gonna have one that surrounds each ventricle, and that's going to be called the endocardium. Endo meaning within, cardium, so it's surrounding the ventricles. And then all this space in here is going to be filled up with probably the most popular and named one, the myocardium. Myo meaning muscle, cardium meaning heart. So it's the muscle of the heart. Now to describe what keeps these valves from opening and closing and what keeps them connected. Well, we have, so yeah, draw back the bicuspid valve. All right. So we have our valves. They're closed tight. They only flow one way. They only open one way and close one way. So it's very important, and it's very important not to have backflow or regurgitation of the blood. So you're gonna have ligaments called, or tendons called chordae tendini. It's called chordae tendini. May need to be spell checked on that, but chordae tendini, and that's attached to little muscle fibers called capillary muscles. Papillary muscles. And so that keeps the valves open and closed when they need to be closed and opened. So they help prevent the backflow of blood. If you have backflow of blood in the heart, you're not going to be living. So you need these valves to be working properly, and you need the chordae tendini there and the papillary muscle there to be working well. Everyone knows if your heart's not working right, there's going to be some major consequences. And there's chordae tendini and papillary muscles on each of the valves, not just on the two I drew here. And so let's see, what else we're going to talk about? Okay, let's talk about the valves some more. So the valves, they're closed and open, closed and open. They work in unison, so both ventricles fill at the same time. So both your bicuspid valve and your tricuspid valve are going to be open at the same time. They're going to be filling, and as soon as they close, you're going to hear a lub. So the popular lub dub, lub dub, lub dub, the sound of your heart, you're going to have your lub sound. When they close, think of a door or a screen. When you open it, little noise, but when you shut it or slam it, and slam shut, it's going to make lub sound. And then similarly, both your pulmonary valve and your aorta valve are going to open at the same time as well. And once they open, no sound, but when they close, you're going to hear the dub. So you're hearing lub dub, lub dub, lub dub. And that's the opening and closing of the valves. And you could already imagine how fast these ventricles fill up and push the blood either to get oxygenated or to be used. So from the right side of the heart, we're going to take deoxygenated blood from all over our body through the vena cava, and it's going to push the blood into the left and right bronchi to get oxygenated. It's going to come back through the pulmonary veins, oxygenated because it's coming out of the lungs, and the pulmonary veins are going to fill up the atrium, and the auricle and the atrium are going to help push the blood into the left ventricle. Left ventricle is going to push the blood through the aorta. The aorta has 3 branches, and it's going to push the blood throughout the rest of the body. The muscles that help keep the pressure is the pericardium, endocardium, and myocardium. The pericardium, to be specific about what it does, it helps surround, and the endocardium as well, it helps surround the heart so the heart doesn't expand too much. It keeps the heart contained. Chordae tendinae and papillary muscle keep the valves from closing and helps have no backflow. And yeah, so we got the tricuspid valve, which just connects to the vena cava. We have our pulmonary valve, which connects to the pulmonary trunk. The aortic valve, which connects to the aorta. And the bicuspid valve, which helps with the pulmonary veins. So cool. If you guys have any questions, shoot me an email. I'll have a link below. Thank you.